Hi friends, today we will discuss the problem on Thevenin's equivalent circuit. So in previous videos we have already seen model 1 and model 2 of the Thevenin's theorem. Now this is model 3. So in model 3 the circuit consists of only dependent sources. Okay. So now we need to find out the Thevenin's equivalent circuit. Okay, so if the circuit consists of only dependent sources, the open circuit voltage will be 0. Understand? So the VOC is equal to 0. VOC is nothing but VTH. That is VTH is equal to 0. Okay, so if the circuit consists only dependent sources, okay, VTH Thevenin's voltage is 0. So we need to find out only Thevenin's resistance. Okay, so to calculate the Thevenin's resistance, okay, if these are the independent sources, we can replace the voltage source by short circuit and current source by open circuit. Okay, but these are not independent sources, these are the dependent sources, so we should not do like that. Okay, so here in this case, so we need to find out the Thevenin's resistance between these two terminals. Okay, we need to find out the Thevenin's resistance between these two terminals. So we need to connect one current source here, okay, otherwise one voltage source. Okay, so to find Thevenin's resistance, so let us draw the circuit. Okay, so here across these two terminals we need to find out the resistance value. So let us connect one current source of 1 amp. Okay, so 1 ampere current source I will connect, and I will find the voltage across this 1 ampere current source. That voltage divided by this current will give you the resistance value between these two terminals. I hope you understand. Okay, so I have connected 1 ampere current source. Okay, so now I will find the voltage across this current source. Therefore that voltage divided by this current value will give you the resistance value, that is called RTH. Understand? So this is 0.01 VAB, this is 20 ohms, this is 50 ohms, and this is 0.2 VAB, this is 100 ohms. Okay, so the VAB is here. Okay, the VAB is here. Okay, now by using mesh analysis we will solve the circuit. So there are 3 loops here, so there are 3 currents flowing. Okay, so the current flowing in this loop is IA, and here it is IB, and here it is IC. Okay, so now the current flowing here is already, this is a current source, so IA is also in the same direction, so IA is equal to 0.01 VAB. Okay, so this is equation number 1. Okay, now let us write for the second loop. So let us start here. So 20 into IB minus IA, okay, plus 50 into IB minus 0.2 VAB, okay, plus, so 100 into, okay, so 100 into the current flowing in this branch IB minus IC is equal to 0. So let it be the second equation. So in the third equation, okay, for this loop, third loop, so this is also already 1 ampere current is flowing, but which is in the opposite direction of IC. So IC is equal to minus 1 ampere. This is third equation. Okay, so and we need to write one more equation. Okay, there are 4 variables here: IA, IB, IC and VAB. Okay, so VAB is equal to, VAB is the voltage across this branch, otherwise this branch, both are in parallel. Okay, so let us write VAB. Okay, so 100 into, okay, so with plus here and minus here, so we need to assume the current like this, so IB minus IC. Understand? So this is the fourth equation. Okay, so if you solve these 4 equations, okay, so there are 4 equations and 4 unknowns. So if you solve all the 4 equations, you will get Ia is equal to minus 1 by 13 amperes. Okay, please solve the circuit, solve these equations, and Ib is equal to, so 12 by 13 amperes, and Ic we already got minus 1. Okay, and VAB is equal to, so 192.3 volts we will get. Okay, so you can solve after getting Ia, Ib, Ic. You can solve VAB is equal to 100 into Ib minus Ic. So you will get 192.3 volts. Okay, so the voltage VAB across this branch, this current source will be 192.3 volts. So RTH is equal to, so VAB divided by 1 ampere, that is current source value, that is equal to 192.3 divided by 1, that is equal to 192.3 ohms. Understand? So now let us draw the equivalent circuit of the Thevenin's equivalent circuit. So plus minus, and this is RTH. So RTH value 192.3 ohms, and these are the two terminals A and B, and this is 0 volts. Okay, so if this is 0 volts, we can replace this by short circuit. Okay, so the circuit is only this one. So this is AB. Okay, so this is only RTH 192.3 ohms. So this is the Thevenin's equivalent circuit for the given problem. Okay, so this completes all the 3 models of the Thevenin's theorem. For first and second model, please refer to the previous videos. Thank you.